This is regarding the European project enhancing and implementing knowledge-based ICT solution within high risk and uncertain conditions for agriculture production systems. This project is a 4-year project that now is presenting some of the results that has been generated in the last 3 years. My name is Dr. Jorge Hernandez, and the title of my presentation today is going to be about modeling and simulation in agri-food domains, the challenge to embrace reality with a variety of simulation tools. The agenda for today is that I'm going to describe a little bit what is the RUC APS project. Then I'm going to cover 4 types of modeling and simulation techniques that we have been using in real agri-food related environments, within the idea that you can understand how different type of simulation tool or simulation method can be applied in different type of environment or different type of domains in a very easy manner. Of course, this work is after several months, several years of work, but you can see more or less how the result will look like. And in the end, the main purpose is that we should make all these tools and solutions understandable for the community. So I'm going to start sharing my screen. So, a second. Well, our presentation mode. Okay. Right. So, Rina, are you there?
Yes, I'm here.
Can you see my screen?
Yes, sure, I can see your screen.
Okay, thank you. So I will rely on you in case my screen got off, so you let me know.
I'm here, yes.
Thank you, Rina.
Yeah, you're welcome. Oh. Yeah, I mean, I thought it was not the case to introduce you. Everyone knows you, so you are our
Okay, but if you want to introduce me, please go ahead.
No, come on. Okay, you can go ahead.
Okay, thank you. Right, so the RUC APS project is a project which is based on knowledge exchange stuff, basically for doing research and innovation, which means that the project is looking out for experts in different areas that can share knowledge in practice, which is a very big challenge because normally research is meant to be performed in a particular area. This research is done or produced in several areas. It's 1.3 million euros, around 1.2 million pounds, is the largest grant in the management school at University of Liverpool that we are leading, and we are right now in our 4th year. The website rucaps.eu is showing constantly all the information that we have around this project. This project in particular has one particular mission, which is about support farmer decision-making when they are facing high uncertainty and risk within a value chain implication view. This means that for us, in the agricultural and the agri-food domain, farmers are the key elements in terms of producing the food that we need nowadays. But as you can see, for instance, uncertainty, which is normally main as a climate change, also can be seen as a regulation aspect, like a Brexit, which is something happening right now. But also we have another one, which is COVID-19, which is another source of uncertainty. But it's still, farmers need to produce the food for all of us. And as a vision, the project is looking at to be a consolidated and competitive international and multidisciplinary consortium to provide participatory and collaborative solutions to agriculture value chain stakeholder challenge and requirement, which means that this project is based on real challenge and real requirement to be addressed, to be useful for the agricultural community. One of the key aspects of this project is that we work in the food supply chain domain where we have several actors. So these actors interact every single day, but normally what happens is that they don't know how they interact, or they don't have enough visibility on how those different layers interact. Therefore, simulations and modeling tools are very helpful to realize or to make them realize how they are really interacting. As I explained before, one of the main drivers of this project is one of the major issues in the last century, which is climate change. Difficult to recognize in early 1900, but nowadays in 2020 is fully recognizable that we have a climate change issue. And of course, this generating a lot of global problems, especially in the way in how we produce certain crops, certain food, and but more especially how we transport or how we trade those food, because there is a quality element that needs to be considered across those chains. So, and because this is not new, but it's generating a lot of issues nowadays, they need to be modeled, they need to be understood, but also we need to see what is the value chain implication from all this. Therefore, from the RUC APS project, we have a visibility in terms of how the value chain looks like. We identify several layers. Being one of the first layers is how we design all the seeds and how we produce all those raw materials to produce this food. After that, we consider all the layers regarding how the crops are going to be produced, and then how it's going to be distributed to the farmers, and then how they're going to be processed, then how this is going to be sold into the end consumers, and then how end consumers are going to use them. But of course, this is not just about that, it's about many other decision variables. It's also about objective functions. Everything is about how projects really can be set in a way that can support every layer, right? And on top of that, we have all the data analytics that we need to consider in order to understand how this is working. So this environment, which can be seen very simple in this picture, becomes very complex once you want to try to understand it in one picture, right? So therefore, we need different models, we need different tools to see them understandable. The RUC APS project is a framework that tries to combine all these complexities from different angles. We have decision support system, we have data management, we have farming life cycle, we have decision making, we have definition and gathering of requirements, we have technology development, we have participatory approach, we have facilitation functions, and then all of this is combined together in order to generate value, especially once we are facing with high risk and uncertainty, which is the main issue nowadays for everybody. Therefore, this project is composed by 7 countries, coordinated by University of Liverpool, and then we have other institutions like University of Plymouth, Riviera Purdue, Innovation for Agriculture from the UK. We have the National Research Council of Agriculture from Italy. We have the Agency of Agriculture Innovation from Italy. We have a Food Innovation Technology Center from Spain. We have the Development and Innovation Institution from Brittany in France. We have the National Institute of Agriculture of Chile. We have Block Smart Thinking companies from Chile as well. We have an operational research center from Poland. We have the Valencian Agri-Group Business Federation from Spain. We have the University of Británico Valencia from Spain. We have University of La Plata. We have the University of Toulouse. We have the University of Nancy. And we have also Farmers, Terviverde, and Digital Stream from Argentina, which means that everybody who belongs to this project, and all of you are welcome to get involved in this project. You can get involved with all these institutions to try to find new collaboration, potential connections, and potential new businesses with them. So the network is open for everybody. You can access anytime the RUC APS website, and then you're more than welcome to get involved or get in touch with all the experts who are very willing to provide you with support, assistance, and also involve you in some initiatives that we're currently working on. The project is composed by more than 100 researchers distributed across Europe and South America. We are creating a very nice friendship and a very nice collaboration where once we meet with people, you really understand how they really think, how they really work. And that, of course, is an essential part of any modeling and simulation process, because the soul of every model needs to include how people behave, how people think. Therefore, without meeting people, without knowing them, it's very difficult to produce a model that is going to be useful, because people will never understand how that model will be really useful for someone unless you meet people who really tell you face to face what they really need. So based on this introduction, I'm going to address and explain those modeling and simulation applications where we have addressed different type of problems from agri-food value chain requirements and challenge, and then in a way that the audience can really understand how the modeling simulation can be something tangible. Of course, this is based on computer-based simulations in the end, which implies a conceptualization process first. And once everything is conceptualized, then we translate those conceptualization or perception from the individuals into simulation tools. Because it's a complex process, there is not always one tool that can address everything. We should be ready to select different tools. And that is one of the challenges of modeling simulation, being able to select the right tool for the right problem. Therefore, we can find the right and efficient solutions in the right time. Okay. So I'm going to do something before I continue. Okay. Just checking that the system was set. Sorry. Thank you. Right. So in order to do all this, we need to answer, first of all, three main questions, which is mainly what be based on this modeling simulation. First of all, we need to understand what is operations management, what is supply chain management, and then what is management in reality, right? Those questions are very big. It's not simple to answer those questions in one single answer, because those questions covers every single problem that you can find in real world. Therefore, the idea of this session is that you may try to answer those questions by the end of this session based on what you will see with the next model. So try to keep those questions in mind. So probably you will remember this, and then we will try to answer those questions together. But keep that everything is about how do we manage processes efficiently. So the first tool that we're going to use, or that I'm going to present you, is about multi-criteria decision-making analysis. This type of tool is very interesting, and also is very helpful, because once you don't know exactly what the problem is, or once you don't know really what is really happening, or what is required to be modeled, or what is required to be analyzed, we need to gather those information. So we need to find a tool in order to do it. So a multi-criteria decision-making analysis can help us to identify, for instance, what are the main criteria to make certain decisions, and then what is the relevance from every criteria to understand which decision is more important. So in theory, this sounds very simple and very attractive, but in practice, of course, this also implies a challenge. So we need to understand what is the value, right? First of all, so in an agriculture value chain, we have three main layers where we have value and goods and services goes around. We have traders, we have processors, and we have wholesalers and retailers. So the key challenge is to be as lean as possible to reduce waste, but also to increase profit and deal with uncertainty, considering that we have climate, market, regulations, and prices in place. So on one hand, we have producers. We want to produce and sell. And on the other hand, we have the market. We want to buy things. So how we can identify what is important at the same time and in the same value for producers and the market. So in general terms, this is a cycle that is a never-ending story, and then they need to be constantly be assessed in a way that we can understand what are the main requirements from everybody. In order to do so, basically, we need to make sure that information and communication is properly in place. So, first of all, we need to understand that consumers, and especially in the agriculture chain, there is a lot of things that need to be understood, especially The concept that who produces first is the one who sells first is something that we need to consider, but then also the market is also some expectations. So, and because the farming products are not very simple to produce at any time, they produce regarding to the season. It's not possible to produce any time to produce all the products. So we need to consider certain challenge, right? So those challenges are regarding to understanding the agri-food supply chain requirements on one hand, which mainly implies to understand what is happening upstream and downstream in terms of these relationships. And then also we need to understand what are the agri-food decision makers aspect that really help them to face several market challenges. So all this need to consider aspects like technologies, nutrition, market demands, economy, political market, food security, climate change. So you can see that just with a few words, this set of requirements are becoming quite complex. So therefore, we need to address them properly. So this research in this particular aspect was oriented to address aspects like climate change in connection with current markets, the need to support a decision-making process effectively and timely, update requirements from real industry problems, and of course to provide a clear visualization on priorities to support the operation management regarding solutions. So the methodology in this case is about to set a pair comparison between a lot of criteria. Criteria need to be gathered from experts, and then every criteria is to be assessed with that numerical value in where we say that if a comparison between certain criteria is equals to 1, that means that all of them are equally important. Or if we set a number 9, that means that some of them will be even more important, right? So this is more or less how the methodology works. Therefore, in this sense, technically, we define what is called the consistency ratio, which mainly after we define all the numerical exercise based on real data, we need to know if this information is consistent or not. And depending on this ratio, we can validate if the information from people is consistent. I mean, in case people is having like different opinions about something, this methodology will help you to realize that. So in terms of steps, basically what we do is that first of all, we identify what are the priorities and what is the main way in terms of the criteria. After that, we identify exactly what is the criteria more important, and then we compute which one is the more important in terms of rankings. So the consistency ratio is normally a basic formula in where we just try to identify how consistent every element is, and then the consistency ratio is the one that will tell us exactly if the opinion from the people or from the expert is really making sense or not, which is a challenge when you do modeling and simulation. So based on a random index table, which is a well-known table, we produce all this analysis. So, but from an operation management point of view, it is possible link theory and practice. So the purpose of this exercise is to show you how do we do it. So considering any uncertain situation that we normally face, we are the most relevant aspect to consider in order to make decision over which good or bad decision will affect positively or negatively each sector. So these aspects are going to be covered in this exercise. So first of all, based on several meetings that we did, like, well, at the moment, 2-3 years ago, and running since then, we have validated a lot of criteria that are important for several type of participants. So we gather with a lot of experts coming from agriculture, coming from business, coming from law, coming from banking, coming from institutions like government, coming from academics, PhD students, master students, people that were just consultants, like people that are supporting the agriculture domain. So based on these criteria, you can see that we have a lot of type of characteristics that can be group all these criteria. So we have technologies on one side, we have agricultural aspects in other side, but also we have the technologies in terms of mechanization, planning, project management, innovation, technology, sustainability. So all these aspects in some way that are eventually important for the agriculture domain need to be linked and need to be understood. So what we did is that we did a consultation, and then we set the ranking of the top 5 and the top 6 criteria and top 5 alternatives. So after all this period of 2-3 years, we were able to identify what are the main criteria for all these people at the same time. And basically we got that is introduce production to more stable market, increase the profit, have a good life by doing farming, mechanize and reduce the costs, establish a firm and selling point, have a quick and reliable access to information. And in order to cope with all these aspects, in order to try to find solution to them, we identify 5 main alternatives. One of these alternatives is offer flexible decision support system tool for different sectors, mentoring farmers for business and entrepreneurship, enhance the use of digital information system for farmers training, provide assessment service to farming to improve food safety and implement a quality control system, and then create a collaborative group dealing with regulation, rules, and law aspects in collaboration with agri-food stakeholders in public administration. So now the question is, in order to face with high risk and uncertainty in agriculture, especially with regulations, what are the main criteria and what is the best alternative? Because at the moment, at this case, once I will show you how we run these meetings, at the moment, at this stage, we just gather more or less what are the most important, but what are really the most important for each of them, for each people. So we run these meetings in 5 countries, right? We did in Spain, with experts in Spain, we did with expertise in Italy, we did this in Argentina, we did this in the UK, and also we did this in Chile. So the thing is that what we will expect that maybe the hypothesis is that some of those criteria or some of those alternatives should be different for each country, or maybe there could be some similarities. But what I'm trying to say right now is that at this very moment, all of we got were perceptions from people, what they think that is important. And at some point comes the time to show that numerically, from a quantitative point of view, which one is more important. So based on our results, right, we can see that in terms of criteria, we noticed that, for instance, for the case of Chile, right, we got a first result, right, where it says that the criteria 4 is more important, right? Criteria 4 is mechanize and reduce costs. So we can see that in Chile at the first time, to rise all these issues with agricultural, mechanize and reduce costs is something very, very relevant for everybody based on this consultation. In the case of Italy, we noticed that the criteria 2, which is increase the profit, also becomes the most important. In the case of Argentina, criteria 3 was more important, which is about have a good life by doing farming. In the case of the UK, criteria 4, the same like in Chile, was more important, which is about mechanize and reduce costs. Where in Spain, pretty similar actually to Italy, is about to increase the profit. Nevertheless, you can see that we have a blue line and an orange line. The blue lines present the very first result, the very first income from people. But those results meant to be inconsistent because basically there are some contradictory questions or some contradictory answers that maybe same expert from the same area are saying different opinions. So we need to iterate. So once we iterate and then we say, are you sure that this is the right question or this is the right answer? They try then to fix a little bit the answer. So we can see that, for instance, in the case of Chile, something that was clear at the beginning that was mechanized and reduced costs, eventually people start realizing that once we made the question again, we noticed that was not just that, but also have a quick and reliable access to information was the most critical one. So we moved from something that was a perception that people think that by mechanizing and reduce costs, you will solve the most of the issues. But then after another consultation to the same people to make sure that they were right, we noticed that in the end, they were looking at have a quick and reliable access to information. In the case of Italy, results were quite consistent since the very beginning. We show that the level of knowledge in this type of population is quite high, and they were very aligned in the first decision. The same case with Argentina. You can see that in Argentina, the answer that were not consistent with the consistent ones really match both ones. In the case of the UK, surprisingly, happened the same like in Chile. They thought at the beginning the most important was also mechanize and reduce costs, but once this got iterated, really farmers in the UK or the farming community, they moved into what they really think that is more important is really to have a good life by doing farming, which is very, very important. And in Spain, we moved from increase the profit to have a quick and reliable access to information, which is very interesting because information at the beginning that you can see the blue line is just perception, but the orange lines now show us how quantitatively we can assess what they really think that is the most important aspect or in which aspect you should focus. This is particularly important in case you want to run project or you want to run solutions or you want to run any modeling simulation in each region, because now you know what they are focused in or what is less important from them. So once you know when people appreciate, especially in the agriculture domain, you know in which thing you should focus on. So we can see that there are similar behaviors in some cases, right? Especially in Chile and the UK, similar behavior between Italy and Spain, and Argentina becomes very consistent. Of course, once we try to see all this, for instance, we can see that in terms of which criteria in overall was the most important, we can see that in overall, all of them, and in Europe, we can see that introduce the production to more stable market becomes one of the most important. And in the second place, we have a good life by doing farming, followed by mechanize and reduce cost, and then criteria 6, which is have a quick and reliable access to information. So this is super important once you want to start doing modeling and simulation, because it gives you the right picture about what the domain is really offering you. In terms of the alternatives, we can see that, for instance, for the different alternatives, Chile is more interested in the alternative 5, which we remember is about the regulation aspect, where Argentina is alternative 3, Italy is pretty similar, but it's also alternative 3. The UK is looking at alternative 5, and then Spain is also looking at alternative 5. So we can see that here there are some patterns regarding to each alternative. So basically, as we said, the most alternative, I would say, create a collaborative group dealing with regulation, rules, and law aspect in collaboration with agri-food stakeholder and public administration is one of the key aspects that is a match in each of these regions, actually. So this type of modeling and gathering the information is a very helpful tool that can really help us to know where exactly we need to go. So now on, once we start doing any modeling and simulation, we are looking at aspects about how we create collaboration, how we deal with regulation aspects, especially with law, and also how we can make agri-food stakeholder and public administration to collaborate better. So with those information in place, you can really set this more clear. Okay. So is going to explain. So the next tool I'm going to explain is about GRAY, which is a graph with results and action interrelated. So then once we understood what were the main aspects to consider, especially with regulation and especially how different actors need to collaborate, we need to understand aspects like what are the objectives, what are the main decisions, what are the actions, how do we measure them, what are the main drivers, what are the main constraints and limitations, and also if there is any key performance indicator that we may consider. Therefore, because the agricultural world is very big, one of the key aspects or one of the key areas where regulations affect the most is in the breeding sector. I mean, how do we produce the new seed for the future? of course, everybody who eats an apple, or everybody who eats a tomato, or any type of fruit or vegetable, of course, the normal consumer, you just see that product in the supermarket, but we need to understand that there is a whole value chain of processes that goes to the initial point, which is when those seeds were designed in order to be commercialized. So in this case, one of the aspects that we noted that are very important, as also not very well understood from the whole value chain, is the breeding process. I mean, how do we create those seeds, or how do we manage them? So what do we do in this case is that for this breeding sector, we understand that there are three types of elements. We have the breeding aspect, is the cropping, and then is the commercialization aspect. But all this lead to one particular element, which is the food safety. So breeding in particular, we can see it in practical terms, something like this. We see a lot of labs, a lot of places where a lot of geneticists are really trying very hard to produce the best seed and try all the phenological types and the phenological behavior. Therefore, you can get the best product, the best crop ever. But there is a lot of uncertainties in the world, like climate change, cost, pesticides, and so on. Therefore, it's not a simple process. That's why we need a lot of iteration. The main issue with the breeding process is that it takes quite a long time to do it. It's not something that you can do from one day to another. Some of those processes may last 10 years. Therefore, you need experts that really can explain you what is happening, and then try to model this also becomes a challenge. Therefore, the tool that we use to model this process, especially the decision-making process, is regarding how different decisions and constraints go through this process. So, in terms of decisions, right, in this breeding process, we need to classify the different activities. So we have activities that are very long-term decisions, right, which is called strategic decisions. We have mid-term decision, which is called tactic, and then we have the day-to-day decision, which are operational. And in terms of this, there are many functions that are around this domain, which is about sowing material choice, breeding strategy, sowing strategy, experimental design, crop management, yield evaluation, product quality analysis, material selection, commercial activities, international regulations. Now, these modeling tools are not designed for agriculture. There are generic tools that once we understand what are the inputs, the outputs, and the processes and resources involved, we are able to adapt those tools to any domain. So right now we are applying those tools to the agricultural sector, to the specific case of the breeding case. So what we do is that we identify all the decisions that are made at every level, right? And we can see that most of the decisions are made at the strategic level, then we have tactic, and a few decisions are made at the operational level. This is because the bottom level is more about executing. So we're not expecting to make many decisions. If you're making decisions at the bottom level, that means that something goes wrong, right? You didn't plan something well, and that will generate a lot of bottlenecks in terms of information and decisions. So then we start mapping the process. So every cell, every decision is composed by the number of activities, resources. So we can see that an example, that particular decision is composed by activities like genetic resource selection, and also we have a breeder involved, we have a genetic report, and we have also genetic resource delivery report. So every decision center, as an example you can see here, is composed by this detail. This is part of the mapping process. So first of all, we need to understand how the information and decision flows and who are the main actors that get involved. So as an example, we can see that we go down, so we have more other activities, and then an example, for instance, in the bottom level, we need to deal with a lot of pesticide selection and then pesticide application, for instance, so which makes total sense. In the top, we select when we're going to do something. In the middle, we say how we're going to do it, and then in the bottom level, we say exactly what are we going to do. This tool is very helpful because once all the inputs and variables are put inside of the tool, automatically it can show us how the different informations and decisions flow through the system. Also, very interestingly, the tool shows us that there are some red lines, for instance, as you can see here. Those red lines means that the tool is telling me something like if I'm really sure about that, because basically what is happening is that there are some decisions that are happening in this level, right, at this in this marketing and sale condition level that was informed to us that they feedback higher levels. And this is very strange that it's happening like this, because at higher level, nobody should make a decision and then inform the bottom level. But basically, this is what is happening right now, and this was a realization for everybody to say, oh, maybe it's something that we should change that in the future, because things are happening, as I said before, in periods like 5 years, 6 years, and trying to improve that takes a while. But a tool like this can really help to see how the information is going, and then can help some kind of a communication with experts that not always are able to see this picture. So once we run the simulation, we can see that automatically in red boxes, the tool is showing us where are the bottlenecks, in green, where decisions are made, and in yellow, where decisions are already made. So, and also in this graph, we can see something that we call the quality of every decision. So this is basically showing that the quality of the system goes down and then goes up again, which is working very well. But what is very important is that we can see that at some point there are many activities in red, which means that there are many activities that need to wait a longer period for being executed, which means that there are other activities that either are not producing the information in the right time, or people also maybe it's not available in the right time. So this also can help to allocate people to the right activities in order to manage this properly. So in terms of quality, for instance, as we can see, every decision center has their own quality. For instance, we can see that the quality of that decision center is very high. At some point goes to 0, which means that basically that there were either not information available, or there were no people to execute that particular decision at that very moment. In this one in particular, happened the same. So we can see that in certain moments, there is something that is not available, but we can see that in some cases, the graph is not going to 0, but also is going to 0.6 or 0.8. This means that something was not available, but the team in that particular decision support were able to cope with that quickly and move along. But when that becomes to 0, that means that something happens that everybody gets stuck and it's a very high bottleneck. Then in the bottom, we see that decisions are very good at the beginning, but at some point decisions become to 0 again, because again, information becomes not very reliable, and then decisions are very difficult to be made. This means that at the very bottom, at the very beginning of each activity, everything is very clear, right? Nothing changed. People can execute their decisions very efficiently, but at some point decisions become more inefficiently because things are starting to change, materials are not available, people is not available, or something happens. So that means that we need a refresh of the information, a refresh on the criteria, and refresh on the requirement to make those decisions. So more important is that what we notice that in general, for the decision-making process, one of the most important resources here is the breeder, of course, the one who designed all the experiments. And also we can see that there are other people that like workers in the field, lab technician or field technician, that are also present in this model. Nevertheless, we can see that the people that invest the most of the time is not the breeder, but also is the field technician, which is also very important because that also helps us to understand who is more available or who is less available. Then basically in terms of possible solution, this picture is very helpful because we can try to think in which decision, which used to be long-term, maybe wait a year or 2 years for them, even 10 years, we can make it eventually more quicker. So then we can reduce those bottlenecks in decisions. Or which decision that maybe are happening too quick in this bottom level, in this operational level, can be done a little bit faster. So in this way, you can interact with the organizations, you can interact with managers, you can interact with stakeholders in a very simple manner, and then they can see exactly how those decisions happen. The second tool, the tool number 3 that we're going to use right now, I'm going to show you, is about system dynamics. Of course, by the end of the session, if you have any question, we can discuss more about this. So, but If you have any question, of course, you can post that in the chat, and then I will try to read them later, just in case. Another tool that we use is we call system dynamics. Basically, system dynamic is about to identify balancing loops and reinforcing loops between certain activities, and therefore we can see how different variables affect each other. And because we know that, we can see what implication we can have in variables that are not directly related. For instance, in this example, we can see that a variable like productivity affects the amount of work to be done, which affect the schedule pressure, which also affect the dispensing error, which also affect the rework, right? But in reality, we don't see a connection between productivity and rework. But if we follow this flow, we can see that there is an indirect relationship. So this system dynamic approach is very useful to measure and to identify those indirect approaches. So the first approach that we did is that we create, with the Ministry of Agriculture of Chile, we create a first coastal loop diagram in trying to understand everything, basically. We gather all the things. Actually, this is the very original picture, which is also in Spanish, right? Because it's the reality. We show us all the variables that need to be considered in order to deal with agriculture once we are facing high risk and uncertainty. And this is very interesting because this conversation is based on experts from different areas that eventually we start talking and talking and talking, and variables start emerging, variables start appearing, and then we come out with very complex but very interesting picture. And this was the source of the motivation for the next models I'm going to show you. So in this particular model, we can see a lot of domains, a lot of areas that make us realize that this agri-food sector is a very complex area, which means that there is room for everybody to produce a contribution. So we have technology transfer, breeding, pesticide management, food safety, regulation, quality, logistics, labors, producers, uncertainty, pricing, and market demand. In the particular case of food safety, we develop a specific model in order to understand what are the implications of certain type of use of pesticides in certain areas, and then what is the implication of in the greenhouse uses, in the region, location, climate change, the type of uncertainties that we consider, what are the implications if we use certain certifications like a global gap, and then what is the implication on cost and so on. So in this conceptual model, we have not created any simulation yet, but at least we know how every variable relates and how are the implications. Then, based on a methodology that we have, we translate this model into the simulation model. So what we do is that every variable, we need to understand what they mean, and then we understand the formulation. So every variable that you saw before in the model is now explaining here, and also we set the units for them. Based on this, we create a simulation model that can help us to understand what is the correlation between all these variables, but also they can make us realize how every variable relates and how those indirect related variables can affect each other. So in this case, for instance, we try to see what is the organic usage, sales expected, what is the food safety level, what is the crop protection level, and then also what is the pesticide usage level. So we can see that in certain areas, this tool helps us to, in some way, run some scenarios manually and automatically. Therefore, we can see, for instance, what happened in certain variables, change their values. So for instance, we can change some objective impact. Of course, this has a context, which means that what are we expecting to achieve? And then we see which variables affect the most of the others. Therefore, experts in this area can really focus in the right variable when they really need it. A model like this is very interesting because this tool, for instance, is a free open source tool that anybody can access this model, anybody can run this model, and also anybody can improve this model later on. So the idea of this is that we're enhancing the collaboration and communication between actors by using those simulation tools. The tool, of course, is not simple to produce those simulations because it requires time. That's why normally we do this in a team. So the team normally gathers variables, or the team gather the correlation between them. Then it's a validation process where finally we come up with this solution. So another example that we did is from the producer point of view. In the same case, we set the closed-loop diagrams in this case for the production, and then we transformed in the same way this into the simulation model. So in the same way, as you saw before, a simulation like this becomes very handleable and very useful. Therefore, we can see how different variables affect each other. So the model is very interesting because it shows us in real time how, for instance, transportation can affect export, can affect distribution cost. We can have labor availability, labor demand, for instance, rainfall aspect, the coal storage. We have the aggregated demand, government taxes, farming income. So all these complexities and all this perception that we got in the first model, if you remember the multi-criteria decision-making model, now you can see how they are translated into the gray methodology model with the decision-making process. And now we can see all the dynamics between all these variables, which is one of the most important parts. Finally, another example is the discrete event simulation model that also has been produced in this project. This type of simulation is really about to understand when events happen, and because we know these events, we can identify aspects like cost, inefficiencies, bottlenecks, use of resources. So in order to do this, we need to understand the process and how every event and state happens. So we use an example from Italy, Alcia, where we have this machine where they understand the phenological behavior of crops in different ways. This is one of the most advanced machines that exists in Europe for these purposes. But this machine is not new. It's quite old actually. It looks very advanced, but there are a lot of inefficiencies and things that need to be improved and need to be considered for this particular machine, even if it's very advanced. Of course, there is people that is working in this area since years, and of course, once this happens, it's difficult for them to see what is really happening in terms of potential improvements or potential inefficiencies that we may add to this process. So we understood this process, and then we translated again into a conceptual model and then into a simulation model. So what we did is that we create a witness-based model from all this. So based on the conversation that we got with people, we identify which variables we want to measure, which aspect need to be visualized, let's say what type of a strategy need to be analyzed, and so on. So the simulation model, in the end, works very interestingly and reflect more or less the reality. What is basically happening here is that every crop is being analyzed in its chamber, and then need to, depending on the condition, need to be reanalyzed again, or to understand their phenological behavior, they need to wait in this very long waiting line. So all these criteria are set into the model, and the model reflects the reality. But basically, one of the questions in this case is about to understand how many labor shall we consider for this, how often shall we consider, how many pots can we produce. So in practical terms, you can see that the tools show us in real time what is really happening across the whole process, and that helps to expert, again, to understand how this works. So this tool gives us the possibility to run several scenarios in order to find the optimal condition, especially for how many pots we can produce. So in this case, we can see that we can process in certain conditions a maximum of 7, a maximum of 20, depending on how many labors we should consider for each of them. So which is very useful because this really helps us to see what is the maximum level of pots that we can produce in certain conditions, what are the maximum or minimum level of resources that we may, in terms of labor, that we may consider, but also what is the maximum amount of, let's say, crops and pots that we can use or we can produce in order to be effective and not overuse this machine and this process. So interestingly, the tools show us that there is no only one solution in terms of number of operators versus crops arrival. There are several alternatives. Again, same way like a multi-criteria decision-making analysis that we did at first. There are several ways in how we can process all this. So just to finalize this presentation, I would like to say final remarks. So modeling is just a tool, which means that it's not the end purpose. So I wanted to show you several ways to show modeling and simulation in agriculture. So therefore, you can see that we don't need only to depend in one single tool. We have several possibilities, we have several alternatives. What's really important is to identify or try to understand what the problem is. Without that, any tool or any model is just useless. So modeling tools help to solve a problem and to find a solution, not the opposite, which means that a modeling is not about to invent a solution and then trying to find the problem for it. We need to find the problem, then we find the solutions. Innovation and open minds are required to excel modeling processes, which means that one of the main requisites to do modeling and simulation is that we need to be able to innovate, but also be open-minded, which means that we need to be able to see the problem from different angles and trying to see that eventually, once we understand the problem, there still may be a different way to solve the same problem and maybe more efficiently. Academic modeling is interesting, but has to be useful and understandable for a stakeholder. And this is one of the main challenges. That's why it's the purpose of all this connection with this RUC APS project. The idea is to show to the industry community that modeling tools are there in order to support them and in order to try to understand what they do. Finally, just to mention to the community, at the moment, we are looking for some PhD applications. If anyone is interested, we have several topics that we are working on. So if anybody from the audience is looking for any PhD possibility with us at the University of Liverpool, we're looking for several possibilities, especially with integrated international food demand and food safety framework, collaborative agri-food decision-making supported by standardized cloud-based tools, risk management strategies to decentralize farming supply chain management, standardized strategies balance producers and consumer preference to better mitigate and adapt to climate change, business management for fresh product packaging and international agri-food supply chains, collaborative strategies to establish food policy in developing countries while facing food crisis and uncertainty in cross-border regulations. And we are very open to accept any application for being analyzed, of course. If you look at the website of the management school, there are some scholarships available you may try to consider if you think that you meet the criteria. Now I would like to ask the audience if you can to access, before making a few questions or answer a few questions, I would like you to access this website. It's www.menti.com and try to put this code 3522A7 because I'm doing a consultation right now about the agri-food value chain challenge that you think that you learned from this session. So if you can access this site right now, it will be good. In the meantime, I'm going to wait a few minutes so then I can show the result, or if anybody has any question, I could cover those questions now. So that's it. Rina, are you there?
Yes, I'm here.
That's it.
Thank you very much, Jorge, for your very nice talk. And yeah, we'll wait for some questions, or we're going to the Menti webpage.
Yes, I'm going to put in the site in case anybody can see it. You can see in the chat we have menti.com, right? And the code I'm going to put it there is 322A7. 322A7. So I'm going to put it there. So everybody's welcome to put your inputs. I forgot. 3522A7. 3522A7. 3522A7.
I have a question.
Okay, so yes, of course. Anybody for a question?
Yes. Hello, this is Federico Paragar.
Hi.
Hi. Thank you for your presentation. Really interesting. And I'm wondering, what's your opinion about, I would say this, if there is a different paradigm of farmer production in Europe and in, I would say, South America. And when I'm thinking that in Europe, I think, well, probably in the States as well, United States, the paradigm is getting food with more for the farmer. It's quality. But in South America, probably other developing countries, still the farmers are looking for volume. And what's your opinion on that sense? I mean, can the developing countries move to higher value, quality-based kind of production, or we will stuck with farmers looking for more volume? Thank you.
Do you mean in these current circumstances, or?
Yeah. In these circumstances.
Yeah, of course. I mean, this is something very interesting because during these RUC APS sessions, we have noticed that volume is not an issue right now, I would say. I mean, nowadays, of course, in order to commit with certain requirement from population, we think that volume is something important. Nevertheless, we noticed that the issue is not the volume, is how we access to that volume, which means that communities, let's say population or certain regions, especially developing countries, are not able to access that volume, which means that instead of having the case we have a scarcity of products, we have an overstock of them. So I would say that at this very moment, the very right challenge is to see how prices of crops go through this supply chain. Therefore, we make the product more accessible. So then we can have the balance between accessibility, affordability, and the volume that you have mentioned.
Really interesting. Thank you.
Yep. So I'm not sure if.
So this presentation will be available on our website, Jorge, isn't it?
Yes, the session is being recorded. So yeah.
Okay.
Absolutely. So I'm going to share a little bit my screen. So I will ask you to everybody to try to access this menti.com 352287. So then we can see what's the outcome. So if you can access that, please, it will be fully usable. So I wish you can see more or less what is the result in a moment. So try to access. So I'm going to share my screen, so then this more or less can help you to see what is the result.
Excuse me, Professor.
Yes, of course. Questions, please.
I suggest you submit the video to any web that we can download it, because right now I'm in China. It is very difficult to see the video on Vital. Yes.
Yes, all the videos are going to be available in YouTube, and also in the website of the project, which is RUC APS. I'm going to write that in the chat as well.
Can I download it? Sorry, can I download it?
Sorry? Yes, of course.
I want to download it. Yes. Oh, I see. That is all my question. Thank you.
Yeah. Okay, not sure is any more question from the audience. Willing to cover many answer. If you can access the menti.com with the code provided. It would be nice if you can put some your comments and inputs. Will be fully appreciated, and I can show to everybody the full picture that's what we got. I'm going to share my screen so you can see how this looks like. I'm going to share this. Yeah, this one. So this is more or less how it looks like. So at the moment we have a modeling as one of the key aspects, simulation tool, strategic, agriculture. So you can put your input. We'll fully appreciate it to get the full picture. So is there any additional question or anything you would like to know about modeling and simulation that caught your attention?
Yeah, there are few people who already submitted the 5 keywords.
Okay.
Yeah, probably we have to wait a little bit more.
Okay, question.
Yes.
Yes.
This is Horacio from Chile.
Hi, Horacio.
Hi. Thank you very much for the presentation. Very rich in methodology and tools. Next week, we have a demonstration series. It is considered to show something of this tool for this week or not?
No, this is not going to be next week. This is just for this week.
Okay. Thank you.
No problem. Okay, we see some progress in the input for the menti.com.
Yeah, it was a very successful talk, Jorge. A lot of attendance, and very, very fruitful.
Yeah, no, thank you to everybody for the attendance. All the time it's a pleasure for me to present results from this project. What is more important, I would like to say that all the time everybody is really more than welcome to attend these sessions, to participate from all our activities that we are doing, because basically it's one of the ways that we can show how real problems can be addressed from a multidisciplinary point of view, which normally is the challenge, I would say. So how we join with different people from different domains, different areas.
Different background.
Exactly, yeah, and also how we understand to make things different, make things understandable for everybody is difficult. But I think that we have done a very nice progress. We are able to understand each other, from the management point of view, from agronomical point of view.
Was not an easy task because we have a very different background, but all background are useful to really have a role in the value chain for agri-food.
Yes, correct.
Yeah, from the research till people who develops also software or tools for commercialization or conservation and so on. So it's very good.
Correct. So, any other question, comment, suggestions? Are you too tired?
So modeling is still the winning word.
It seems, yes. Well, I would like to use also this opportunity to show you that tomorrow, let me see, tomorrow we are also plenty of sessions as well. So everybody is welcome to attend in this website. Of course, don't forget to register to this. And in terms of the agenda, tomorrow we have more sessions with Maria Gonella from Italy, Maria Valemani, Optimization Modeling in Agriculture. We have presentation from CN Arispa, and we have presentation from Chile as well. So you are very welcome to attend those sessions, everybody. All right. So if there is nothing else to say, I think that
yeah, no more questions.
No more questions. No more comments.
Audience, we have still 90 people attending.
Yes.
Thank you very much.
Hello.
So I hope some of you, or a lot of you, will participate also to the other sessions in the next days and the next weeks. Thank you, Jorge.
No problem at all.
Più che altro, diciamo, per completare il quadro di...
And, and
yeah, some people is.
Yeah, and see you tomorrow.
Yeah, see you tomorrow, of course.
Okay.
See you tomorrow, Jorge. See you tomorrow.
See you tomorrow, my friend.
Hello.
Thank you for everything.
Thank you very much.
It was a very, very, very interesting.